Good morning, ladies and gentlemen. Now we start our next session in our conference. So I would like to invite Professor Atulgiri Mayagiri Gonsai sir. Please come on the dais for our chairperson in our session. Please, sir. Okay. Now I would like to Dr. Sangeeta ma'am, please, sir, give the bouquet to the sir for welcoming. Thank you so much, ma'am. Now, it is a great honor and privilege for us to welcome Dr. Sanghyuk, our distinguished computer science with deep expertise in security, wireless communication, and network optimization. Dr. Lee has made significant contribution to the field, having served as an assistant professor in the Department of Computer and Communication Engineering at DGSIT, South Korea, and previously as a postdoctoral researcher at KAIST, one of the South Korea Premier Research University. Please, sir, start your keynote speech.
Have you seen? Can you hear? Hello.
Yes, sir, visible.
Okay, so I think you can hear what I'm talking. So I have to start the presentation, right? Okay.
Yes, sir.
Thank you. So yes, presentation title is the hesitation analysis on the intuition 40 set and its application to the decision making. And the content is constitute decision making and the hesitation, brief introduction, and also more main analysis on the hesitation inside of intuition 40 set. And it's a graphical illustration and also example. Finally, we do discuss and making a conclusion. Okay, as you are aware, decision measure is very decisive for the decision problem, right? Sometimes we're using the Smith measure, also entropy, something, right? And next one, we do need to data transform to the fuzzy set because rough data and the initial data is needed to change it to the fuzzy membership value. Fuzzy membership values include certainty and uncertain data, right? In the rest of information, rest of data, we do say that is a hesitation, right? It's very important for this hesitation, right? And it is obtained from the total information. Total information is also to control decision making and pattern recognition, definitely, right? So we now propose the proposed coordination, right? Okay, it is applied to the congressional election case, right? So we do continue for the next one. Oh, sorry. So I have to delete for this one. Okay, now I delete. Okay. Oh, I think better. Yes. Okay. So from the definition of intuition fuzzy set, it can be illustrated for the universe of discourse. Over the universe of discourse, X, X means that it's not a time sequence, right? It's event-driven something. And set A is defined as domain value and also membership and non-membership case, right? Each value is lies in between 0 and 1. Normally, it satisfies its summation from 0 to the 1. This first information, maybe you are very clear and you know well for that. And Atanasov defined the hesitation value. It is the rest of this certainty and uncertainty from the total information one. So in the other way, we can say that this membership value is can be, we do consider is the affirmative kind of preference. In this non-membership case, we do say as a dissent kind of object. Yes. And this consideration is a little easy to apply to the example that we are trying, right? Okay. Then we do, this is very important concept, this presentation. Thing is, actually from the definition, we can say that membership and non-membership value itself, right? And the kind of membership and non-membership value, right? And it is given some value, then, and we are not sure that this is the measurement. If it is a kind of, for example, we can say that it's a 0.4. Yes, 0.4 is measured from the 0, right? Origin. But from the total information is, we do consider just one is total information, right? Then it can be measured from the bottom, kind of a null information. And if it's a full information, it's in here, right? So we do let, if membership value is 0.6, then we do measure from the null information, it satisfies 0.6, right? Okay. But in the other, if we consider that is measured from the full information, then rest of this one, we to say that this, yes, complement meaning of 0.6, right? So from the coordination, proposed coordination is like this. And we do measure mu plus value is measured from the bottom. And in the other meaning of a non-membership case, and we can be, if it's a 0.2, can be measured from the full number, right? So we do coordinate is a nu plus, right? And the other opposite case, we can measure for this nu value. If we measure from the bottom, we do define as a nu minus from here, right? This. And that is little interesting, right? We can illustrate for this case, for this value, can be illustrated for this one. If we're making a rectangle coordination and the mu plus and as a mu minus, and that is nu plus and the nu minus case, then we can say that here is, for example, if there is 0.6, here is 0.6, right? Okay, and the mu minus become the 0.4 and the 0.4 in here, right? Okay. And how come? Yes, non-membership case is measured from the point 2, from the full information. That is point, yes, here, right? And the other one, if we measure from here, can I say nu minus k, if you measure from here, it becomes the 0.8, right? That is value, right? Okay, we can make this kind of a quadrangle, right? Okay, how about this blue line? Blue line is how come this rest of value, absolutely that is 0.2, right? And can be extended to the 0.2. And we can draw this kind of quadrangle again, right? Same as, yes, here and here can become. And there are two quadrangle, right? Yes, we using this, for this information, we can draw like this, yeah, quadrangle. So here is the basis to apply for this kind of hesitation analysis, right? Okay, so I do continue for this one. Okay. So by the relation and membership, mu plus and mu minus become the total information, right? Yes. Here is mu minus, it include the hesitation value. And here also, mu minus also include the hesitation value, like this, right? Okay. So for example, calculation example illustrate. For the intuition for the set A, mu plus and nu plus is satisfying 0.8 and 0.1. And another intuition for this set is 0.6 and 0.3. Two intuition for this set that has the same hesitation value, right? Like this. But the illustration of this quadrangle is different, right? And we can say that it's different. Yeah, we can show like it has. Look at this. Yeah, here is the illustration. Look at that. Here is, yes, B. And this one is B. Can say right again. Okay. Here is a B. Here is the A, right? Okay. Yeah, it's very interesting, right? Look at that. Here, two intuition forces that has the same hesitation, but from the proposed coordination, its shape is different, right? And what does it mean? Yeah, we can get the instinctive, let's say, knowledge for this. In this case, look at that, the intuition force at B. This one is this crossing point, and we focus on this crossing point, right? And for this A and B comparison, here is a very interesting result, right? From the new coordination, very interesting, because you can say from the intuition force set A and B, which one is, yes, in this case, A is rather close, actually says A is, sorry, here is the force set A, right? A is rather close to the decision, right? Rather than this one. This is rather mild than this one, right? So we can say that this one, I do have to say this one is A, sorry, this one is B. That are close to the origin, right? In the visually, we do have an idea for that, okay? Yes, procedure is following like this. And from the figure, we can illustrate this crossing point become the very important information, right? Okay, yes. So this one is a calculation of a procedure, right? To finding out this, yes, crossing point, right? So this is the value for the crossing point, right? So using this calculation, we can find the hesitation, this one, you can see, sorry, this is another let's say, formula, but this one, look at this. Yes, I will calculate for this area. I'll do, this area. As I said, if the IFS is close to the origin, it means that letter affirmative, right? Then this area is a little smaller. It becomes that it goes to this origin. It means the more affirmative. So this area can be calculated by this procedure. Actually, there is a crossing point calculations to follow in the later, right? Here is just we to derive this area, right? So by the calculation, A is much less than the B, right? It means less hesitation, right? With a numeric value, we can illustrate, right? Okay, look at this map. It's a South Korean map. And there was a 22nd Korean congressional election, right? And the red one is Conservative Party, and the blue one is Progressive Party, right? So Conservative Party, they do got the totally 90, and the Progressive Party, they got the 161. And we do investigate for each district, and for the decisive case, such as this area, it's better to, yes. Yes, in this, especially in this area, and in this area is very decisive, right? Okay, so, and a very decisive area, even in the Seoul, some area is very decisive, right? And by the calculation, some case was very commutative, right? Yes, we will investigate this type of commutative, yes, area by the result of, yes, previous hesitation illustration, right? I will show one, two districts in that is, where is, sorry, where is, okay, yeah. Maybe you can recognize well, this is very decisive area, right? Very decisive district. And here it's very competitive, right? Actually say, in this case, very easy to predict for the result, right? But in here, it's up and down, right? And in this case, very difficult to predict, right? But at the beginning of campaign, and the red one is less, a little higher, but it becomes the up and down, until finally become the red one, right? So not easy to predict, but we can illustrate with the hesitation, right, case. Okay, so from this one, look at this. This district decisive case, affirmative membership is 37%, right? And mu B plus is 0.37, sorry. Look at this. Data is changed to the, like this way. This one is vote, like a final vote. And in between the election duration, there is a census poll, right? And A candidate got the 37%, and the B candidate get the 44%. It means that 37 is supporting this candidate, can be illustrated as a 0.37. And the 44 case is a yes, 0.44. That is indicate no plus case. Oh, sorry, here is A, right? Yes, competitive case also same, right? But as I said, it's not easy to predict, right, the value. Okay, I will just explain with shortly for the result. Yes, by the comparison with the two candidates, you can see this one, blue candidate is a little close to the origin. It means that this blue candidate is very high affirmative than the candidate B, right? In this case, very easy, right? But that illustration of for each candidate A and B is showing like this way, right? And as you see, this crossing point is very close to the origin, right? Okay, how come this? Yes, this crossing point, how to calculate it? Yes, by the derivation, we do have quadrant 2, yes, this x and y value. And quadrant 4, yes, also illustrate, right? Okay. Yeah, in the sum district, and we do calculate for each crossing point, and like this way. And for the candidate A and the candidate B, how come this? Yes, as you see, in this case, red candidate is very close, right? Closer than this candidate, blue one, right? This candidate is very decisively close to the red one, right? This average value we can illustrate as a granular computing, right? We can compare for the several districts with the competitive case and this 1, 2, 3. Oh, sorry. And we can see this one, this is very competitive, right? But these two cases very decisive. We do intentionally select like a very decisive case and yes, competitive case, right? Okay. So yeah, this is the value. We say like this average value with the granular information we do make, right? And by the comparison for the competitive case letter, yes, for the quadrant 2, this point is lies between this 0.35, right? And but the decisive case is a little closer, right? A little closer than because that is 0.25 case, right? Okay, we have like can change it. We have changed it to the intuition for set data with the hesitation to the visualizing, right? So it is also providing kind of a calculation step, yes, that is come from the membership, right, value and the non-membership value, right? It indicate, and how come this one? It's a little decisive for the election case. The value is 0.19 to the 0.28, yes, like this, right? Okay. And how come? Yes, little competitive case is little coming to here, right? Okay. Also, we do calculate for the winning rate, right? By the calculation of this several example of district and final result, loser and winner value. This point 3663 and 0.332 is that the value of this average value for this point? Yes, this point average value. So yes, we can say that this, as you say, these two values very competitive, right? Because if this value is close to the origin, that means yes, a little affirmative. Okay, so where is the okay, right? Yeah, these two values a little close, right? As you said, so that's the competitive. In this case, it's a little difference, right? For each case, little decisive, right? So we can say from the result, yeah, and how come this one? This, sorry. Okay, so totally we do calculate from the total as is the winning rate is yes, we can calculate for the winning rate. Okay, finally, we arrived to the conclusion. We propose hesitation visualizing, right, with the proposed coordination, right? Okay, and membership line in the quadrant 2 is related with the affirmative degree, and the quadrant 4 is the dissent degree. So it area also area calculation also proposed, right, with the corresponding coordination, right? Also, information granule is a crossing point summation, otherwise average is indicate this kind of this value, right? Oh, sorry, this value like this. Okay. And in the example, we can illustrate it's a prediction, but still very difficult for the competitive case. Yes, for the prediction. Okay, this is my end of presentation, and here is a reference. And if you have any question, let me know. And also, if you want, I can share for this study. Right. Thank you for your attention. Any question? It's done my presentation. Thank you. Okay. I don't.
Okay, thank you so much, sir. Your insightful and inspirational keynote, your valuable knowledge and experience have greatly encouragement of this conference. Now, I would like great honor and privilege for us to welcome Dr. T. Velumurugan, a distinguished academic, researcher and leader in the field of computer science. Dr. Velumurugan sir currently serves as Assistant Professor and Head of the PG and Research Department of Computer Science at DDGD Vaishnavi College, Chennai. With decades of experience guiding research scholars, he has made significant contribution to the field of machine learning, data mining, classification algorithm, and statistical data analysis. Dr. Velumurugan sir has published over 140 research papers in the reputed journals and conference and has been an invited speaker at international conference worldwide. Ladies and gentlemen, it is my privilege to invite Dr. T. Velumurugan to the stage. Let some warm welcome, round of applause as share his expertise with us. Welcome you, sir.
Slide. Good morning. Good morning, all. It's my pleasure to say thanks about this conference for having inviting me as a keynote speaker to this auspicious function, that is International Conference on AI. Thank you very much for the organizers, especially my friend Dr. Manu Pratap Singh and Ganesh Chandra and other head of the Department of Computer Science and other faculty members. Thank you very much. First, actually, this is a research paper, it's not a general topic, my speech. The title of the research paper is Emotion Detection Through Students' Emotion Data Using Machine Learning Algorithms, in which how the students' emotions are actually gathered and identified, and finally how we can able to predict the students' mindset in order to improve their talent and other concepts, understanding the subjects and finding the behavior of each and every student. Everything is included in this research work. Next. Next slide. Sir, next slide. What is the agenda of this entire research work? First, we have to introduce the general concepts and then review of literature, then description of data set. The central part of this research work is materials and methods, then finally conclusion. Usually, there are number of research work are carried out by using the data mining and machine learning techniques nowadays. Because of its easy usage of the algorithmic approaches. There are many people are taking the research work based on the machine learning algorithms nowadays. So the machine learning algorithms are efficiently carried out, utilized for the purpose of many fields, not only in the field of the emotion detection, also in all fields such as artificial intelligence and other neural networks and quantum computing and other kinds of high performance computing anywhere else. So that this research work utilizes only finding the emotions, through the emotions of the students, how we will be able to find out the students' mindset. That is the main concept. Next. So the teachers can better understand the students' feelings by using this machine learning algorithms, which provide a potent way of automatically extract, categorize, and interpret these emotions. These emotions means from the students' emotions. For that, we have to show a picture to the students. From that picture, how the students are given commands, whether they are joy or feel better or angry with the picture, or what kind of emotions produced when we show a picture, thematic text, thematic picture image. So that this research work utilizes such kind of thematic picture is shown to the students, and then we will get the feedback from the students. From the feedback, we can predict the students' mind, students' emotions. This is the main goal of this entire research work. Next. So literature work, there are many literatures, there are many people are done their research using the same topic, emotion detection. Okay. Something are given in this. Next. So there are many people utilize most of the machine learning and data mining algorithms, like such as support vector machine, k-nearest neighbor algorithm, and other algorithms are multi-layer perceptron, and other algorithms are utilized. Some informations are alone are shown in this slide. Next. This is the simple architecture of this entire research work, in which first we have to consider the data set. The data set, actual data set contains raw images, that is some inconsistent images, unwanted images. In order to pre-process in order to remove the unwanted information or smoothing the information, we should do pre-processing techniques based on the data set. After the pre-processing work is carried out in this research work, then we can apply the machine learning algorithms. There are two machine learning algorithms, random forest algorithm and logistic regression algorithms are applied. And then there is a hybrid algorithm actually combined with both regression analysis and as well as the random forest algorithm. A hybrid algorithm is coined. The total, finally, from the students' emotions, what kind of actual research work done by that is this researcher, this is the actual core of this work. So there are many methods before. The data set actually contains 3,420 students' comments. This is taken from the Kaggle data repository. 3,420 out of this 3,420 students commands, we can identify several kinds of the informations. Next. So in order to ensure the textual data which is clean, so already I have informed why we require the pre-processing techniques. If we take in the raw data, it contains inconsistent data, unwanted data, noisy data. For smoothing the entire information, so we can utilize the pre-processing technique. After the pre-processing technique, we will carry out the research work. Next. So what are the pre-processing techniques are available, utilized? Stop word removal, upper to lower case conversion, punctuation symbols removed, stemming and lemmatization, tokenization. Stemming, lemmatization and tokenization. These are the pre-processing techniques actually used in this research work. So all these are actually 6 kind of pre-processing is carried out based on the data actually collected from the Kaggle repository. Next. So that the main algorithm which are applied in this research work is logistic regression algorithm. You know that very well. What is the? It is a very popular algorithm. Many people are using the same logistic regression. The regression analysis in statistics, you know that very well. Finding the relationship between 2 set of data or more than 2 set of data is the concept. Next. So random forest algorithm is, already you have some idea. Random forest algorithm is one of the #1 decision tree algorithm. This is also utilized. Combining this both random forest algorithm and logistic regression algorithm, a new proposed hybrid method is coined, which is named as random forest plus logistic regression algorithm, RFLR algorithm. It's a hybrid method which combined by using both algorithms. Next. So next we want to discuss about the results, experimental results. The students' data set is fully based on the text-based commands. The students are given commands based on the text. Okay. So next, the text-based commands are actually applied and given input to the both algorithms after the pre-processing. After the pre-processing, the information is taken and given as input to the random forest algorithm and logistic regression algorithm. After the random forest and logistic regression algorithm, the hybrid algorithm is utilized. That is important. Okay. So that the first step is the pre-processing, second step is the machine learning algorithms, namely two algorithms. The third step is the hybrid algorithm which are applied in order to find the students' emotions. Next. This is the results of pre-processing for each and every word. Word conversion, uppercase to lowercase, tokenization, stemming, lemmatization, everything is displayed here. The raw data first and then the other 6 kinds of information, so pre-processing are applied. Okay, next. Before. So you can note here, the predicted emotions are joy, sadness, anger, fear, love, surprise, and got like that. Some of the information. Out of this 3,400 and something data set, the word joy appears from the students' comments is listed here. How many commands, how many times the word joy appears? 288 and got like that. This is the pictorial representation of the same results which are yielded by the algorithms. This is the results of the random forest algorithm. Next. This is the confusion matrix for the random forest algorithm. You can identify easily what are the impact which are given by the algorithm. Next. So this is the predicted information of the LR algorithm, logistic regression algorithm. So you have to consider the entire text which is available left side, in which key factor, which key text is available, joy is available. So how many people are utilizing this joy? How many people are utilizing the word love? Unquote like that. This is a textual based analysis exactly carried out. Next. So frequently identified by LR algorithm, the word joy appears 112 times, fear appears 343 and got like that. So this is the confusion matrix of the algorithm. Next. So the next concept is the results of the hybrid algorithm, RF-LR algorithm. Here also we can have some results. The words which are joy, fear, and love, angry, sadness, what kind of emotions are actually given as command by the students, which are all taken into account. And then the words are identified. Next. Next. So this is the hybrid algorithm's results. The word joy appears 842 and got like that. Very easily we can identify how many times the words that appear for this hybrid algorithm. Next. So this is the confusion matrix of the algorithm. Next. So finally we can conclude this research work how much the accuracy of the algorithms are actually identified through this research work. The random forest accuracy have 83%. Logistic regression accuracy is 81%. But the hybrid algorithm yielded 94% of the accuracy. So that compared with the existing algorithms, random forest and logistic regression, our hybrid algorithm yielded better results. Other than that is yielded better results compared with the other two existing algorithms is the main concept of this research work. Next. So that we can conclude, this research work conclude traditional algorithms such as random forest and LR algorithm, the random forest with this ensemble based decision making is actually carried out, and then this data set is actually applied. When applied individually for the algorithm, the results are not good. But if you apply the the hybrid algorithm, the result is better compared to the other algorithms. So already I have already told the research work summarizes the key findings highlighting the effectiveness of this algorithm. Through this research work, we can able to identify the students' emotions in order to better identification of the students' mindset, how we can improve the students' teaching and learning process, everything is concluded. But through this research work, the actual hybrid algorithm got high performance and other two algorithms are less compared to the hybrid algorithm. This is the final conclusion of this work. Thank you very much. Thank you. If you have any questions, you can ask me, no problem. Actually, this is my students' work, it's not my work. Always, whenever I going to speak, I will use one student's paper. In my profile, some people's, that is the introduction, I have published 140 papers. No, more than 250 papers I have published. My H index is 25 and I-10 index is 35. That is important. So thank you very much for giving me this opportunity. Thank you.
Thank you so much, sir, for sharing your invaluable insights and inspiring experiences with us today. We are truly grateful for your time and guidance. And I would like to invite our organizing secretary, Dr. Ganesh Chandra, sir. Please give it to bouquet and memento. Thank you to sir. Thank you so much, sir. Now, we break for 2 minutes and then after the session start. Another session. So here, uh, next session. So I would like to invite Dr. T. Velumurugan sir for chair this session. Thank you so much, sir. And now we are deeply honored and privileged to welcome a truly visionary in academic and internationally academic researchers and distinguished leaders in the field of computer science, Professor Dr. Atulgiri sir. Sir has been inspiring force with more than 2 decades of dedicated teaching path, breaking research and academic leadership. His outstanding journey is over of 120 research paper, 8 authorized book, 11 patents with several grants and 3 copyrights. His contribution have been recognized globally with highly prestigious award including the AICTE Career Award for Young Teacher, the Outstanding Academician of the Year 2024 and most recently the Lifetime Achievement Award for 2025. So here, sir, please share your insights keynote speech.
Good afternoon, all of you. Good afternoon again. And before I start, thank you very much for introducing myself, and I thank all the organizer for giving me an opportunity to share my views. And I am working on artificial intelligence, wireless networking and other area. But today this is being an invited talk. I have tried to make my presentation on the future of artificial intelligence and machine learning in our computer science. So this way I have prepared my slides just to ignite your minds, being a student, being a researcher, being a PhD scholar, being a young faculty to start and pursue a new research in our area. And finally, after this presentation, I would like to say what are the current trends in artificial intelligence and what are the future trends in artificial intelligence, so that you can think about your next research that can give impact after 2 to 3 years or maybe 5 years. So most of the students are thinking on the current, but we have to start our research by thinking the future, so that your research may not become absolute. So in my topic, I am going to say about artificial intelligence and machine learning, a revolutionizing future of computer, and these two buzzwords are dominating the entire research area. Please next. Hello. Next slide. Just to overcome this problem of saying next, 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 I tried to put my laptop with me so that I can make next slide by my own, but the cable was not up to the mark. If I put my cable there, then you are not able to listen me. So that ultimately my goal of having my own laptop not satisfied. And here if I say that today I am saying that there is a huge impact on artificial intelligence and machine learning, and this system enables how we can adopt and make system intelligent decision. Most of the time nowadays we are using artificial intelligence things in day-to-day life, and this is providing us a certain decision making capability and getting our work done through easily. And this drives mostly in automation industry, providing effective data design, effective modeling design, as well as innovation in business in research. So this way artificial intelligence is not only providing the backbone, but it is the idea which is providing the strength with the help of machine learning. So without machine learning, artificial is nothing, artificial intelligence is nothing. And artificial intelligence is a global set in which machine learning is providing it as a subset value to assist our decision making process. If we talk about some historical points, that you can move to the next, no problem. In historical points, we are aware that computer came into existence in the year 1940 to 50, and in 1956 the artificial intelligence came as a birth. So artificial intelligence is not a new subject. Even when I was a student in the year 1997, before 25 years, 27 years, on that time as a student I studied artificial intelligence. But nowadays the artificial intelligence and its impact is seen in our day-to-day computer science industry. Because when we were studying, artificial intelligence was only a concept, how we can make our computer think. And on that time there was a two gentlemen, in the next slide I am going to say, they raised the question in the conference, there was one international conference, and said, can computer think? Then this concept came as a artificial intelligence, and still that artificial intelligence concept was there, how we can use that thing in computer. In earlier days our computer were only a decision making with the help of serial program execution. Serial program execution means on that time we were using the word expert system, and that expert system is providing certain expertise decision that we can take by a human mind. Nowadays we are saying that computer can also take a decision without using the human mind with the help of artificial intelligence. Actually, you give me my laptop. No, if it is not required, I am audible to you because my voice is very louder. लाइए मिस्टर So, in the year 60-70, the concept was about artificial intelligence and machine learning, but it was only an expert system. Expert system means where a system is analyzing the data, preparing charts, and based on that charts, as a human, we are taking certain decision. On that time, artificial intelligence was there, but there was no processing power. Our computer were very slow, and due to that we are not in a position to execute huge amount of data to be processed in our computer, and we can run and get result instantly. But after the invention of after the invention of a personal computer in the year 1980 onwards by IBM, and this personal computer was capable enough to process data independently, then a new generation started. And after that, combining number of small computer, personal computer, we have designed cluster computer. If you can remember the word cluster computer, where 5 to 10 computers are combined together as a unique one computer, and later on it was combined by 100 computer or 1000 computer and become a supercomputer. And after that our processing power increased, and we are able to run some artificial intelligence based application. And nowadays, after the invention of supercomputer, cloud computer is nothing but a very high processing power computer located somewhere else, and we can get access through remotely. We pass our data to be run on a cloud server, and we get result back in our computer back, so that we can easily run high processing power. And that's why cloud computing is providing a better facility nowadays. And due to that, we are today talking about generative AI, large language model, and AI ethics. So this large language model and generative AI requires huge processing power, and this is become possible because of the high processing power computer available in the market. Now I would like to say, when I was a student, on that time we were studying artificial intelligence, and on that time we are being said that artificial intelligence is nothing but a how computer can think. I would like to say, because being a large number of students and few researchers and teachers, I don't want to make you more bored, because you have been said that you have to sit in this hall and you have to listen. But at least you are here, you can enjoy something, you can learn something. And that's why I would like to raise a question in front of you, and just to make this session lighter. Otherwise what happens, that here speaker are speaking and you have no duty, you have to only sit and listen. And nowadays listening capacity is reducing day by day. Everyone wants to speak. But when I was a student, on that time we have been given certain idea how computer can think, and we were writing certain codes by this way. And on that time we studied certain heuristic search. If you can remember the word heuristic search, it is nothing but this search is being utilized by the Google and all search engine. that will give the faster searching from the data located in different sites and location, and you can get it back in your computer. I would like to raise one question, that if you all students after row number 3, because I am seeing that up to 1, 2, 3, there might be some faculty, researcher or PhD scholar, but after 3, all white shirts, dress are student. I hope so. So the question is to all students, that you give me one answer, that I am planning one picnic for you people in the area of Gujarat. In the Gujarat, you have to come directly to the city Rajkot. In the Rajkot city, there is a surrounding is a forest. Inside the forest, there is one big hill known as a Junagadh hill station. On the top of the hill, there is a base camp for you people. You have to reach before the night. It is a dark jungle. There is no mobile services. I am saying well in advance. And you have to reach to the top of the hill. You are the outsider. There is a dark, dense jungle. You have to reach before the dark night. Now, by chance, few of you, or maybe one, got delayed, and he reached after the dark, after 7 o'clock. There is a dark night, and you want to reach to the base camp. How will you reach to the base camp? You can think out of box or think in of the box. Can anyone reply? Just I am trying to make this session interactive. This is not only a research, I am also a researcher. Even madam said that I have 13 patents, and I am working on elbow X-ray image and bone tumor, and that patent has already been published, number of research paper, many things. But based on the audience, I am shifting some of my focus to make you aware. Can anyone reply? How will you reach on the top of the hill? You are the completely unknown, there is a dark, dense jungle, and you want to reach. Yes? Huh? Yes, this is the right answer. Sometimes people start thinking that how I will reach. But ultimately what is that? Whatever the steps, you will move upwards to the hill, which will be the nearer to your destination. Which will be nearer to your destination. And that's why this type of thing, earlier it was applied, our human intelligence applied in artificial intelligence, and that algorithm has become heuristic algorithm. Whatever the steps upward to the hill, which will ultimately put you near to your destination. That was our human mind. And based on this human mind, we applied on the algorithm and given the name heuristic algorithm. And heuristic algorithm is now applied in all Google and other search engine to get information rapidly and derive it fast. That algorithm has been developed before many years, but this all become popular because of the new computing power. In my days, we are running certain program. On that time, once we compile, it was taking 10 minutes or 15 minutes to compile only program. And again, after compiling, we have to identify all errors all together. Nowadays, you are compiling, and for one error you are compiling, for one error you are compiling. We are compiling only once in a day and identifying all errors together. And after that, we are able to run, because our computer was very slow. Nowadays, after the invention of personal computer, supercomputer, cloud computer, you are in a position to execute your algorithm very fast. After executing your algorithm very fast, you are able to run high processing power intensive AI based application. This AI based application is nothing but our artificial intelligence is human mind applied in a computer algorithm. So who is intelligent? Ultimately, human is an intelligent. And that human intelligence we are writing in a code and applying into computer. Once applying into the computer and it is running, that's why the new word came into existence, that is called machine learning. Machine is, earlier we are saying a machine is a computer machine and a dumb machine, and whatever the idea we are applying, that will be executed by the computer. But now what we are saying, that whatever the idea we are applying on the dumb machine, it is executing, and we are trying to make machine learn and give next time better result. So this concept came into existence after the invention of a computer and fast processing power, so that machine is learning. Now to learn machine, again human mind came into existence. Can anyone say that if being a child or not child, have you heard many a times that there is a one candle burning here? Do you put a finger on the candle to test how it is burning? How many of you? No one. Because we have been taught from our childhood that beta don't touch it, you will get burned. Or some of the time, some child, curious child, many a times try to touch also. And once they burn, then next time onwards they are not. There, on that time there is a perception that to touch, we are not able to survive because it is burning. Same way, that perception takes place in our future decision. That perception takes place in our future decision. So whatever the perception we got in our past record, that we are applying for the future decision. For any other fire, do you put a finger? No, because we are applying that perception for a future decision. Same way, artificial intelligence was there where we applying our minds. Machine learning is now capable enough because of this data, because of this all high processing power computer data. And after that, we are trying to make machine intelligent, can think, and machine can learn based on the huge amount of past data. Nowadays, daily billions of posts are there in X and Facebook and Instagram. Billions of videos are being uploaded in Instagram and YouTube. Number of data are generated by different companies. So there is huge amount of data available. Share market, number of companies, share price for daily up and down and all these things. Huge data is available for us. So what we are doing, we are getting this huge amount of data and processing and feeding in a computer so that computer can take a decision based on our human mind, based on our past experience. I am taking my future decision. Same way, if I put all huge amount of past data, feed in a computer, and then I am trying to get some future decision making process, that is called machine learning. And this machine learning has become possible because of this computer high processing power. And this is possible after the 2010. You can see there is a concept of deep learning revolution, and ImageNet, speech recognition, and present day large language model are able to run because of high processing power. And for this slide, I have already said that in earlier days our computer were only automate task and solve the complex problem. But nowadays, with the help of artificial intelligence, in the year 1950, there was a two pioneer. One is Alan Turing and the second one was John McCarthy, who are the two person who are the pioneer, and they raised the question, can computer think? On that way onwards, artificial intelligence came into existence. And I have already said what is machine learning and artificial intelligence. Artificial intelligence is a broader way concept, and machine learning is a subset of a artificial intelligence. And there is another concept is a deep learning. Deep learning is again a subset of a machine learning with the specialized data for processing. And I already said what is artificial intelligence, and this conference is also talking about artificial intelligence. All the intelligence of our human mind we are applying in a computer is nothing but a artificial intelligence. Same way, the machine learning, the machine can have a ability to learn from a data and from make a precision decision. And this machine learning, as just now I said that we need to pass certain past data. Machine learning can give a better predicted result if you have a huge amount of past data. If you do not have a huge amount of past data, then machine cannot give the proper answer. This proper answer is in terms of accuracy. In all machine learning related algorithm, most of the people are focusing on the accuracy, and my previous speaker has also said that he was applying some machine learning algorithm like decision support vector, as well as a decision support machine, as well as a hybrid algorithm. And hybrid algorithm was nothing but a combining one or two algorithm together, and then you are identifying some better accuracy. And confusion matrix was there, whether the machine has predicted result is actually the result in the area. If machine is predicting right and it is actually wrong, that is called confusion matrix. So nowadays almost people working on the artificial intelligence are using the existing algorithm or combining one or more algorithm and generating the parameterized list in terms of a confusion matrix, accuracy, and another test to identify the effectiveness of the algorithm. But this all algorithm come under the machine learning. And in machine learning, we require certain algorithm, we require data set, past data. Based on the past data, we need to divide certain data for a training and certain data for a testing. And by this way, we can use the automated decision making process. For example, I have a 1 lakh of data for the student behavioral pattern. I am simply giving the example of my previous speaker. So student behavior is happy, sad, or maybe in jolly mood, or in love, or in other way. Some data are there. I have 1 lakh of data, so I want to test it. So what I do, out of 1 lakh of data, 80,000 data I put is separately for a testing. This is general ratio 80-20, and 20% data I put is as it is. So based on 80%, I am training it, and then I am applying this 20% because this 20% data has already result. Now I am applying this 20% and on my algorithm, and my algorithm is predicting some other result. Then I am comparing with the existing 20 to 20 actual result, and based on that I am finding the accuracy. If the accuracy is proper near to 100, then I can say my algorithm is giving the better result. If accuracy is down, then I am in doubt. So this all is possible with machine learning, different algorithm. And if you want to apply machine learning, then what you need? You need algorithm, training, and huge amount of training, testing data. Based on that, you can prepare a model, and that model you can test it with your accuracy for your better result testing. And if we talk about the machine learning, we have a majorly 3 types of machine learning. One is a supervised machine learning, another is a unsupervised machine learning, third one is a reinforcement learning. If we say supervised machine learning, on that time there is a certain data which has a label, certain data which has a label. You can see I am giving one example, that is a spam detection in email. So in email we give the label as a spam, and based on the past label, and this way we are identifying that all our emails are spam email, these all our emails are the promotional email. So Google is trying to use that all data analysis with the label. For example, share market price. So this number 102, for example, this is nothing but a share market price of so and so company share. So in the supervised machine learning, we need certain data. In unsupervised learning, there is a only unstructured data where you can do some grouping. For example, here I am using the example customer segmentation, identifying the distinct group of the purchasing history. So nowadays all online partner like Big Billion Days by Flipkart and Amazon sale, and these all are identifying your pattern of purchasing, and based on that they are giving certain promotional marketing to you people. And for example, I want to give you one simple example for the row number 4 onwards. I have a 1000 or maybe 1 lakhs of pictures in my phone, about 1 lakh picture. Out of that, some human picture, some animal picture, some mammal picture, some birds, different types of, some flowers. So what can I do with this? So if I apply this unsupervised learning method algorithm, what I can do, I make some group. These are the animal group, these are the flower group, these are the human group, these are the mammal, animal. So that way I can segregate my data and do it for analysis. So that is called unsupervised learning. And third one is called reinforcement learning. Reinforcement learning algorithm is nothing but it is on trial and error base. If you give the result and if you give the feedback that it is good, then you are in the same direction. If you give the feedback in the wrong direction, then it is going on the identifying the new way, new path. And nowadays you see that ChatGPT, Gemini, Meta.ai, Grok, everyone is writing in the bottom line, can give wrong result. And it is also asking this way, that way. So once you click on it, it is trying to identify that the feedback is wrong. I have to regenerate output in a different way. So these large language models are currently using the reinforcement learning method. And if we see, these are the current machine learning. There is one concept is going on with a deep learning and neural network, artificial intelligence, which is inspired by the human, and it is using, example here is a Google photo, automatically identifying the objects. If you have a mobile, in the mobile you have a Google photo application and you have not done anything, it is automatically reading all the images and identifying the objects. I want to search photo having fire. If you search fire, it will automatically fire. I want to search photo having hill, it is automatically searching from the photo, because they are using some deep learning algorithm and they are identifying the image data and reading image data. This is the current research going on with the artificial intelligence. Same way, natural language processing, and better example is ChatGPT. You can ask any question and it is understanding human-like question. We are giving the human-like question and it is answering human-like answer. So that is nothing but a natural language processing. In previously, we are supposed to give certain commands. Based on the command, it was considered to be a natural language processing. In before few years, it was considered to be only a translating from one language to another language. Now that is become common, but it is directly trying to give huge amount of question answer with all provided large amount of books in the training data set. And that's why the name they are using LLM, large language model, because they have a huge amount of data in the training. They are putting all the books, billions of books in the training model to identify the English language. And that's why they are using the word large language model. Another concept is going on with Edge AI. And nowadays this is also important one and required. Edge AI and federated learning. This is currently a need of the society. And in the Edge AI, you can see Edge AI, all the smart devices and IoT sensors are reducing the cloud reliance, because these are the small devices, all are sending all data to the cloud processing and then coming back to our mobile. For example, in mobile, there is no much processing power. It is taking data from our mobile, passing it to cloud, processing it and generating result back. Many a times in the mobile, you are trying to use some dictation mode. Whatever you are speaking, it is taking as an audio, passing it to cloud. Cloud is processing and generating the text back and displaying in your chat. Because mostly we are reliable with the background cloud, and cloud is only located somewhere distance and we need internet. And for that, our data is passed from our local mobile to cloud, processing and coming back. There is a problem of latency. And the problem of latency is that it is taking some more time, not instantly. And to overcome such situation, there is a concept of edge devices and edge AI. And this edge AI is nothing but our devices, IoT devices, smartphones, smart devices, smart home devices are located here, and that all processing training is done at the local computer, not on the cloud. By this way, you are reducing the data timing from local server to a local device to cloud. You can see the Google Gboard keyboard. This is Google Gboard keyboard is trying to learn from our local mobile. In the mobile, whatever the spelling you are typing, based on that it is predicting it locally, not going to the cloud. They are simply passing the AI model in the local cloud to our Google keyboard. It is processing locally and then predicting. We need not to pass entire data to the cloud. And by this way, latency has been reduced. Same way, explainable AI. This is also a new concept currently going on. Explainable AI, where crucial understanding of complex AI decision. Mostly they are using in the healthcare to diagnose recommendation. If same way, my work is also there that we are based on the X-ray elbow image, we are identifying the bone tumor. And we have tested many cases, and based on that, we are identifying the person having bone tumor or not. But based on the AI algorithm, how the bone tumor I have detected, that also I have to explain to my doctor so that the doctor can take decision properly. So this is called explainable AI. Currently the need of the society is that we have to design certain AI-based application which can be explainable. Whatever the result it is generating, why it is generating the result, it has to give in its explanation. Based on this criteria, I am selecting this result. Same way in the morning, in the inauguration session, Manu Pratap ji said two stories. One was an ancient story with a new one with the Chat GPT story. Chat GPT said that they select one initially. But why it is selecting one? Because it is not giving answer. That current Chat GPT has a problem of bias. Current Chat GPT, all AI model has a problem of bias. And how it is taking the result, we don't know. And same way, when the Grok launch, you might be knowing that a Grok launch on that time, Grok was, if you ask some question related to our country India and related to Arunachal Pradesh state, whether belongs to India or not, then all other chat model, AI model was giving right answer, but Grok was saying it is wrong answer. Why? Because when the Grok model trained on that time, they have put certain bias, and that's why it was giving all the information negative to our country like India. AI model is okay, but the feeding is wrong, so that it is giving wrong answer. To overcome such situation, nowadays people are saying that you have to focus on explainable AI, and the new word is XAI. You have to design your application with XAI. You are saying that I am suggesting this recommendation, then you have to say that I am suggesting this recommendation because of this point. Based on this point, I am suggesting this recommendation. In the morning, Manu Pratap sir said that ChatGPT said select one. It was right that if you buy three, if you get three women in one house, how you can manage? So ChatGPT said need to also say that I am giving my result because you are not in a position to handle three women in one house. That type of explanation is also required. If I am saying that you have a bone tumor, why my computer says you have a bone tumor? Because based on this parameter, my computer is suggesting you have a bone tumor, and this explanation is also need to be given at the end of the decision. That's why this is important. Nowadays, all a large language model, we are using anything, they are not giving any explanation why this result is selected by the AI agent. And these are certain real world application. We can see the number of healthcare application, in the finance transaction, in autonomous vehicle, and mostly Tesla autopilot. It is also using image processing as well as distance, as well as auto planning, as well as edge AI. Tesla autopilot is using the edge AI. Edge AI means it is locally taking decision, not going to the remote processing. And that's why it is taking faster decision. Otherwise, if it is going on the cloud, then it was not in a position to take decision very fast. Same way in a cyber security, I would like to move fast. These all topics currently I am showing here, this is just your igniting minds. You can think of any one topic and you can do your research. That spam detection in email, they are mostly using the supervised learning model. As I said in the beginning, supervised learning requires data, label data. Label data means all the email has certain label. So this is the application of a label data, and you can see in the spam detection, the algorithm naive Bayes classification are giving better results. You can see it here, naive Bayes classification are giving widely better result. And you can also apply with certain new algorithm, and then you can combine the hybrid algorithm, you can test it. If you want to see certain further reading, you can see Google email uses advanced spam detection method combining traditional email and deep learning. You can see this research paper, and that research paper is also giving good information. Spam filtering with naive Bayes, a comparative study. From this paper, I took this line. Same way, there is a customer segmentation. Customer segmentation is an example of unsupervised learning method. You can have a study of clustering algorithm and case study. Same way, AlphaGo, you are not able to see. Don't put me on this side, you keep this slide only. Okay, so that these people can have a view on it. Even I can also see. AlphaGo is also using the reinforcement learning. I said that machine learning has 3 types of learning: supervised, unsupervised, and reinforcement. So here AlphaGo was developed by DeepMind, and this is using the reinforcement learning. And based on that, in the year 2016, they demonstrated machine complexity in complex decision. By playing the game, giving the feedback, it has reached to the destination. If you want to read further, mastering the game of Go with deep neural network and tree search, this paper 2016 is giving better information about deep learning algorithm. Okay, and there is one also a book on reinforcement learning book by Sutton and Bartok. You can go with only reinforcement learning. Same way, image processing. Google photo, just now I said that in a Google all the photos are there, you can search with any way. And this image processing is internally using the convolution neural network, CNN, and based on this algorithm, it is identifying the photo, people, object, scene, and searchability. You can have a one good important paper, deep learning by good fellow by this person, and there is also a one Google photo technical white paper. Technical white paper is nothing but a company is publishing the technical paper with how the Google photo is searching. That white paper is saying about Google images. Same way, natural language processing, you can see this chat GPT. Same way, edge AI, all the smart home devices processes data locally on device instead of sending it to cloud, reducing the latency and preserving the privacy. And this further, if you want to use edge AI, you can go with this paper. Same way, federated learning, Google Gboard. So instead of executing on the cloud side, we can run on the client side. Same way, explainable AI, I said that once I am generating any result, why it is generating this type of result. This is IBM Watson detecting the cancer, and here also it is generating the result and giving the explanation. This is fraud detection in finance. Same way, certain impact on the society and industry. In the society, we have to check about the economic transmission and ethical consideration. Nowadays, the major problem is ethical consideration of AI in our society. And if we talk about the upcoming future, how you can do, one is quantum AI, which is providing exponentially very high processing power, and due to that, some application we are not able to simulate. For example, I want to simulate the traveling salesman problem throughout the country. On that time, huge amount of data if I am passing, currently this application requires years to process, that can be done in minutes with the quantum AI. Quantum processing is nothing but there is a quid bit. Instead of our binary computer 0 and 1, here it is a 4 bit. And that way it is giving you high processing power. Same way, we need human-centric AI. Currently, we have a AI, but which is not a human-centric AI. Same way, we need responsible AI and ethical AI. Same way, we need Industry 5.0 supportive AI. So, once we use certain artificial intelligence application, which will be a supportive to the human, not the replacive to the human. And toward general AI. These are the certain some emerging application in the future you can use. I am going a little bit fast because it took a lot of time. This is the same way. This is quantum AI game changer. Real world quantum AI impact. You need AI application which is with partnership with the human, not the replacement. In the healthcare, we need explainable AI which will give the justification of the decision. And in AI model, we need, the biggest problem is ethics. How this is generating the result, we need fairness, accountability and transparency in our AI. And you can see IEEE, if you are aware with the IEEE, most of you are aware with the IEEE standard and all this. IEEE has started AI application development with transparency and fairness. It is giving the transparent result, and why this result is selected, that is also giving. So IEEE has started the new AI standard of transparency. And the path to go, currently we are at the narrow AI. Okay. In the long term, we are going for general AI. And in between, we have an enhanced AI. So AI is also evolving by day, and with the help of AI, we have to identify certain problems. How we can shape our tomorrow? By today. This all new technology with research frontier, the decision taken with AI development, AI ethics, implementation will determine the future. Most the problem is ethics in AI. The future of AI is not predetermined. It is a choice we make together as a researcher, leader and global citizen. It is our all responsibility. And in short, there is a certain challenges in AI, data privacy. Recently, all ladies have put sari photo in Gemini banana. But you are exploiting your photo with the Google. There is no data privacy. Algorithm bias. Based on the algorithm, whatever the data you give, based on its own sequence, it is generating the result. Because the algorithm has a bias, I already said, Grok was giving wrong answer. Another is energy consumption. This high processing power requires lot of electrical energy, lot of cooling station, and that is also creating problem in our environment. To overcome, in conclusion, I would like to say, I urge all researcher, industry professional and students to adopt responsible, innovative mindset to ensure AI techniques serve humanity ethically, effectively and sustainability. So, in short, this all new technology is going to change our computer science future. But for this new technology, who will lead? You people, you student and you new researcher will lead the new AI technology. If you have any doubts, interactive session is open for you. You can raise a doubt or session, question, whatever. Look, if you are writing a research paper for social science, then you can generate and you can say that this is generated result as on this date. It may be different is the next time. Okay. It is based on the current data, past feedback data. If you open Chat GPT, on that time you read the Chat GPT release note. In the Chat GPT model or currently Gemini model 2.5 release note says that we have a knowledge between these to this. This model has a knowledge between year so and so to so and so. It has no more knowledge before that year and after that year. You can take its help because it may generate wrong result. They are also writing. You can take it for a reference only. Doing in a social science, you have to rely on the real data. You can use help for processing because it has a bias. Anything else, because I took a lot of time and even I said that you have to be justify the title. So I try to give the AI model current, past and future. Anything else? Because there is a lunch time and I am taking more time. Yes, you can adopt and you can further refine for your further processing and you can use it. But if they provide. Hello. Yes, you can use, you can test with their biological structure for finding a path of a fungus and that fungus impact you can cite as a reference that this was their impact on that research, but now I tested with my result, it may be different. You can use. Any more, or should I sit, or madam is on the dais again? Thank you very much. I thank all the participants because you listen me properly, carefully, giving me a chance to share my views. Because I also do research, but today I was trying to justify the title of the conference so that uh, past, present, and revolutionizing the field of AI in computer science I took, and different area I chose it here so that you can identify further reading and you can start your future research. Thank you very much.
Valuable knowledge and insights with us. Now, I would like to Dr. Rekha ma'am, please come and give the memento and bouquet to ourselves, sir. Thank you so much, ma'am. And here. It is a great honor and privilege to welcome Ms. Jyoti Shah, an IEEE senior member and a visionary technology leader. With our 18 years of experience, divine digital transformation and innovation as Director of Application Development, she leads a global team on cutting edge generative AI initiative shaping the future of entrepreneurship technology. Ms. Shah is not only a full stack expert within front end frameworks like Angular and React and back end platforms like Java and Spring Boot, but also a mentor judge at global hackathons and an advocate for women in technology. Her commitment to inclusive diversity and empowerment has inspired countless professionals worldwide. We truly privileged have Ms. Jyoti Shah with us today as virtually to share her insights, experience and visionaries for technology and leadership. Please share your views, ma'am.
Today, I will present my research on agentic AI for autonomous user interfaces and microservice evolution in cloud platforms. The motivation here is simple. Organizations are already using microservices for modular backends and micro frontends for modular UIs. But keeping these two evolving layers in sync under constant delivery pressure is real challenge. So what we are going to look at, why the current approaches fall short, how an agentic AI control plane can solve this, the architecture, mathematical models, and the real world results, case studies from e-commerce, SaaS, and multi-cloud, and finally future data. So imagine you're driving a car. The steering wheel and the brakes are automated, so you don't need to worry about controlling speed or turning. But every few miles, you're forced to pull over open the hood, and manually tweak the engine just to keep moving. That's inefficiency. That's frustrating. And it's error prone. Well, that's exactly what happens in today's microservice architectures. We have automated a lot of the infrastructure, scaling, routing, deployments, but the actual code level adaptation, the engine of an application, still relies heavily on manual efforts. So I want to explore three big pain points we face: coordination overhead, release velocity gone wrong, and limited automation at the code level. Each one sounds technical, but they all come back to a single truth. The more microservices we have, the harder it is to move fast without breaking things. So let's start with coordination overhead. When microservices evolve, say an API endpoint changes, the front end often breaks. And the bigger the company, the more teams are involved. Suddenly, what looked like a small change in one corner of the system ripples outward like a domino effect. In a startup with five developers sitting in the same room, you can lean over and say, "Hey, I renamed this field." Done. But in global enterprise with 40 teams spread across time zone, it's not that simple. You rename a field at 10 a.m. in New York, and by the time someone in Bangalore wakes up, dashboards are broken, customers are frustrated, and support tickets are piling in. The real kicker is that coordination doesn't grow in a straight line, it grows exponentially. If you have n teams, the number of communication channel isn't end, it's n times n minus 1 divided by 2. That's why companies like Amazon and Netflix have entire governance structures, API gateways, contract testing, firewalls, because without them, the overhead crushes velocity. And let's be honest, most organizations aren't Amazon or Netflix. They don't have those mature send endless Slack messages. So what happens? Engineers spend more time in meetings than in code. Product owners get nervous because one delayed API update can snowball into a delayed feature launch. How many of you had a front end break because someone silently changed an endpoint on the back end? That's coordination overhead in action. It's the invisible tax we pay for flexibility of microservices. Let's go to the next section, which is release velocity. Now let's talk about the release purpose. So we celebrate speed, move fast, break things, right? Many companies push multiple releases a day. But here's the paradox: the faster you move, the more fragile your system becomes if you don't coordinate. Picture this: the backend team renames customer ID to client ID, seems harmless, but the front end team is still testing the UI against the old schema. Suddenly, the checkpoint process breaks in production. Overnight, thousands of customers sees error. This isn't just a technical hiccup, it's a business problem. A broken checkout isn't just a bug, it's lost revenue. A broken HR portal isn't just an inconvenience, it frustrated employees and lost productivity. Release velocity without alignment isn't velocity at all, it's chaos. And then comes the tension. Products push for speed, engineers ask for stability, QA wants more time. Release manager sits in the middle, juggling priorities and absorbing the stress. The best analogy I can give you, it's like running a relay race. Everyone's sprinting, but in the middle of the race, one runner decides to change the shape of the baton. Suddenly, the handoff fails and the whole team stumbles. That's what happened when the velocity outpaces alignment. Let's go to the third challenge, which is limited automation. Let's give credit when it's due. We have automated a lot of infrastructure: Kubernetes scales pod, traffic routes, CI/CD pipeline handles deployment. All of that is fantastic. But here's the catch: none of these systems fix code level issues. None of them adapt your React component when a schema change. None of them auto patch your business logic when an API contract drifts. This still requires a human developer to stop what they are doing, write the patch, test it, review it, and deploy it. This is the gap. Infrastructure is automated, but semantics are manual. And that gap is costing us time and reliability. Think again about driving analogy. You are in a self driving car, and then what happens? Every mile you still have to get out. And yet, that's how software automation feels today. Now, imagine a future where this isn't the case. Imagine agentic AI controls the detect a schema mismatch between front end and back end, generate a patch, test it in a sandbox, and roll it out automatically. Instead of human writing glue code, intelligent agents reconcile system in real time. It sounds ambitious, but it's coming. Until then, we are stuck manually turning engines while pretending we are driving autonomous car. Every decade or so, we see a major shift in how we design and operate systems. More to microservices, manual deployment gave a way to CI/CD pipeline. Now, as complexity scales beyond human capacity, we are at the threshold of another leap. Systems that not just automated, but intelligent, adaptive, and governed. That leap is what we call the Agentic Control Plane, or ACP. This is the heart of our proposal. ACP isn't just another orchestra or controller. It's a new architecture that blends reinforcement learning, large language models, GitOps, service meshes, and human oversight in one cohesive nervous system for modern software. So there are four planes of ACP: the observation plane, the cognition plane, the execution plane, and the policy plane. And I will explain to you how these matters more than ever. Let's begin with the observation plane. The observation layer is all about sensing the state of the system. You can adapt to what you can't see. So, what do we use? Open telemetry for distributed tracing, logs, and metrics. But we extend it further: contracts and drift detection between front end and back ends. Why? Because in microservice, one of the biggest challenges is drift. The front end expects version 3 of an API. The back end quietly moved to version 4. Suddenly, error rate spikes, dashboard fails, user complain. With the drift detection built into the observation plane, the system can flag this before it ever becomes user visible. Think of it like a nervous system. Your body constantly monitors temperatures, balance. The observation plane does the same for software. Latency spikes, schema mismatches, throughput dips, and here's the kicker: this plane isn't passive. It doesn't just collect telemetry, it structures data in a way that upper planes can actually reason about it. It translates noisy metrics into meaningful signals. Without a robust observation layer, cognition and execution are flying blind. This is the foundation. So let's move on with the cognitive plan. So, this is where things get exciting. This is where ACP goes beyond traditional controllers and starts to think. We introduce specialized agents. Some are powered by reinforcement learning, trained to make scaling decisions. Imagine an RL agent observing traffic spikes, constant constraints, and SLAs, then deciding in real time how to scale services up or down. Not rule based, but adaptive, learning from patterns over weeks and months. Then we add large learning model. Why? Because not every change is numeric. Sometimes you need a code difference. Sometimes you need to adjust a configuration file. LLMs are capable of generating these changes intelligently, proposing a YAML update, rewriting a Docker file, or even drafting a front end patch. But cognition isn't just an action, it's analysis, planning, and simulation. Before applying a code diff, the cognition plan can simulate the impact. Will this config change break downstream dependencies? Will this rollout increase error rates? These agents provide the answer. This is the AI driven brain of the system. It mirrors the automatic computing principles of analysis and plane, but with modern intelligence baked in. The next is execution plane. All the observation and cognition in the world means nothing if you can't act on it. Execution is where plan turns into reality. Your ACP leverages GitOps. Why GitOps? Because it provides versioned, auditable, and declarative infrastructure. Every change, whether it's a config tweak or scaling a decision, pushed as a commit. Nothing is hidden, everything is traceable. Next, service mesh controllers. These handles the fine-grained control of traffic, progressively shifting workloads, balancing canaries, rolling back if the error budgets are breached. Progressive delivery ensures changes don't hit 100% of users at once. Picture this. The cognitive cognition plane proposes a code difference. The execution plane commits it to the Git, rolls it out to 50% of the traffic, monitors the result, and then either scales the rollout or reverts automatically. This closes the loop from observation to cognition to execution. Think of this plane as muscle, the doer, that turns insights into outcomes. And finally is the policy layer. If the observation is the nervous system, cognition is the brain, and execution is the muscle, then policy is conscious. Every action must be checked against guardrails, audits, and human in the loop thresholds. Why? Because intelligence without governance is chaos. Guardrails ensures compliance. Don't scale beyond budget. Don't roll out tested patches to production. Don't touch certain mission control services without explicit approval. Auditability is not negotiable. Every decision made by an agent must leave a paper trail. What was observed, what was proposed, and why it was executed, and under what constraints. And most importantly, human remains in the loop. ACP isn't about removing humans, it's about augmenting them. Critical threshold triggers approval workflow. This agent wants to change the payment service config. Do you approve? Human validates, system adapt. This balance between autonomy and oversight is what makes ACP practical. It's not blind automation, it's governed at autonomy. So when we think about automation today, we often imagine a single AI model making decisions in isolation. But the real world isn't that simple. Our systems are too dynamic, too complex, too risky to trust one voice. That's why the cognition plane of the agentic control plane doesn't rely on a single agent. Instead, it uses a team, a multi agent system, where each agent has a specialized role. And here's the innovation: it's not just about having agents, it's about making them work together safely under the enterprise governance. So we will unpack the four agents over here: the scaling RL agent, the release LLM agent, the UX contract agent, and the superintendent agent. So I will show you what each one does and why it matters, and how together they form a collaborative, policy aware brain for modern systems. So let's start with the scaling RL agent. Scaling is one of those things that sounds easy in theory. Add more instances when traffic spikes, scale down when it's quiet. But in practice, it's tricky. Scale too late and you drop request. Scale too early and you waste money. This is where reinforcement learning shines. The scaling RL agent observes pattern in traffic, latency, retries, and error rates. It learns over time when to auto scale, how to adjust retries, and how to limit concurrency safely. Instead of fixed threshold like scale up at 70% CPU, it adapts to real usage and business priority. It might notice that scaling slightly early prevents cascading failures, or that limiting concurrency in one service protects another critical part downstream. Think of it like a thermostat that doesn't just react to current temperature, but learns your habit when you're at home, when you're away, when the energy is expensive. The scaling RL agent does the same for system resources. The result: smarter outscaling, fewer outages, and better cost efficiencies. The next agent is the release LLM agent. Now, this is all about keeping the lights on. But what about the change? Change is constant. New bugs, new features, config updates, and the change is risky. This is where the release LLM agent comes in. It combines the retrieval and tool integration to propose code changes. And here's the key: it just doesn't spit out the code, it provides human readable rationales. It tells you why it made a suggestion, what signal it used, what risk it sees. Imagine you are a developer. Instead of combing through the logs to guess why a test is failing, the agent says, based on the error traces and contract mismatches, here is a suggested difference for the API call, and here why it resolves the issue. It's not about replacing developers, it's about augmenting them, giving them a co pilot that reduces toil, speeds up safe releases, and keeps human in control. This is AI, not a black box, but as transparent partner. The next agent is the UX contract agent. Now think about how many times front end and back end teams fall out of sync. The back end renames a field, the front end doesn't catch up. Suddenly, user sees broken forms, failed logins, or missing data. The UX contract agent tracks user experiences, budget, and contract test. It ensures that UI and the API changes land together, not separately. It's like a project manager dedicated to user experiences. It constantly checks, are we meeting latency budgets? Are contracts still valid? Are error rates creeping up? By acting as a watchdog for user experience, this agent prevents the small mismatches that often cause the biggest headaches. So, in short, it's the glue that ensures user never feels the pain of misaligned team. Finally, let's meet the superintendent agent, the referee. So, when you have multiple agents, scaling, release, UX, each one is optimizing for its own domain. But what happens when the goal conflicts? The scaling RL agent might want to add more resources. The release agent might want to push a new feature. The UX agent might demand we slow everything down to protect latencies. Who decides? That's where the superintendent steps in. The superintendent agent arbitrates among agents. It weights risk, governance, and service level objectives. It says, yes, scale up, but hold that release until the error rate stabilizes. Or this UX regression violates a policy budget. Block the rollout until it's fixed. It's like a conductor of an orchestra. Each musician or agent is talented, but without a conductor, the music collapses into noise. The superintendent ensures harmony. So what collaboration? So we have met the agents individually, but here's the magic. Together form a collaborative, policy-aware, multi-agent system. It's not just about the intelligence in silos. It's about agents negotiating, sharing signals, deferring to governance, and respecting enterprise guardrails. And this is where ACP goes beyond traditional automation. Most systems today automate infrastructures. ACP adopts adoption, and it does it safely. With every agent's decision flowing through policies, audits, and human in the loop check. This collaboration is breakthrough. This is what could turn chaos into coordinated intelligence. So when we talk about microservices, we usually think about backend. But in today's world, the front end is just as fragmented, just as complex, and just as critical to user experience. That's where micro front end comes in. They give us the same modularity that microservices gave the backend. Teams can build, deploy, and scale UI fragments independently. But here's the challenge. When backends evolve quickly, how do front end keep pace without breaking? How do React and Angular application, each with their own quirks, stay in sync? The three key patterns of micro frontends show how the agentic control plane ensures performance UX don't regress as systems evolve. So the first pattern is runtime composition. This is where frameworks like React or Angular use module federation to dynamically load remote bundles at runtime. Imagine your application as a shell, and each micro frontend is a Lego brick. At runtime, the shell asks, which brick do I need today? It then pulls into those bundles dynamically. Say a card component from one team and a recommendation widget from the another. The benefit? Independence. Teams can deploy on their own schedules. They don't have to wait for a monolithic build. But the trade off is complexity. Runtime composition means you are stitching together live paths at the last second. You can run into version mismatches, latency in loading bundles, and waterfalls that hurt your first meaningful paint. This is where ACP steps in. It watches metrics like React suspense waterfall. If it notices that runtime composition is slowing down your first paint, it can suggest prefetching strategies or lazy loading alternatives. So, runtime composition is freedom, but with ACP as a coach to prevent it from turning into chaos. The second pattern is build time federation. Here, instead of pulling bundles at runtime, we stitch fragments together earlier during server side rendering or static side generation. Think of this like a meal prep. Instead of cooking everything a la carte when the customer arrive, you prep meal in advance and plate them quickly. That means faster first paint and more predictable performance. This pattern shines when SEO and initial load time are critical. For example, a new site built with Angular might use SSG to stitch together different contained modules into a single page. The user opens it and boom, everything is read instantly. The trade off is flexibility. If a team ships a new fragment, you need to rebuild and redeploy the shell. You lose some of the runtime dynamism. Again, ACP provides balances by monitoring metrics like build time, cache hit ratio, and first paint speed. It can recommend which fragments should shift to build time federation for performance gain and which should stay runtime for agility. In other words, ACP helps up meal prep intelligently without sacrificing freshness. The third pattern is mixed framework shell. This is where things get interesting. A React host can import Angular elements, vice versa. You can have a hybrid application where different parts of the UI are written in different frameworks. Why would you ever do this? Because large enterprises don't start from scratch. One division might have invested in Angular for years. Another team may be building new features in React. Throwing away everything is too costly. So mixed shells lets you integrate both worlds. You wrap Angular components as web components inside a React host or embed React elements inside Angular. The danger? Inconsistent look and feel. Users don't care if the button was built in React or Angular. They just want it to feel the same. That's why shared design tokens are critical. Fonts, colors, spacing, and accessibility rules flow consistently across frameworks. Here again, ACP watches. For Angular, it tracks change detection cycles. For React, it looks at the suspense waterfall. If one fragment starts slowing down or drifting from UX budget, ACP suggests optimizations like caching strategy or refactoring hotspots. This ensures the hybrid doesn't feel like a Frankenstein's monster, but like one unified product. So, what's the ACP advantage? What it ties all these patterns together. It's like the ACP, the agentic control plane. Without it, you're left managing metrics manually. Engineers to dig into the Chrome dev tools, trace waterfalls, and hope they catch regressions before the user feels them. With the ACP, the system itself is constantly watching framework specific signals. For React, it knows where suspense waterfall hurts. For Angular, it detects costly change detection loops. It then suggests optimization proactively. That means as backend evolved, new API schema changes, service migration, the front end doesn't just keep pace, they adapt intelligently. The user never sees the friction. So, when we talk about adaptive system that scale, heal, and optimize themselves, the real question is how do we formalize that behavior? We don't want random trial and error. We don't want blind automation. We want structured intelligence. And that is where mathematical models come in. Specifically, we can frame adoption as Markov decision process or MDP. So let's go through this step by step through this framing. First one, the states, what system observes. Second one, the action, what levers it can pull. Third one, the reward function, how it balances competing goals. And fourth one, the learning approach, actor critic reinforcement learning with entropy regularization and safety layers. So let's go into each section deeply and let's see how these models ensures adoption aren't just reactive but optimized across multiple objectives. Every NDP begins with states, the system's perception of the world. In our case, states includes three categories of signals: back-end matrix like latency and error rates. For example, is the payment API responding under 200 microseconds? Are 500 errors creeping up? Mesh metrics like retries and circuit breaker trips. If retries are spiking, that's a leading indicator of service stress before outright features happen. Front end RAM, real user monitoring, particularly core web vitals, largest contentful panes, first input delay, and cumulative layout shift. These are what users actually feel. So the state isn't just about servers or containers, it's a holistic picture: backend health, service mesh, resilience, and end user experience. Think of it like a pilot cockpit. You don't just watch few levels, you monitor altitude, weather, and passenger comfort. The system state space must capture all these dimensions. Once you know your state, next question is what actions can you take? In this MDP, actions fall into three buckets: scaling replicas, increase or decrease number of instances to handle load; toggling feature flags, enable or disable functionality dynamically. For example, turning off a heavy personalization feature if latency budget are exceeded; generalizing schema adapters, creating complexity, creating compatibility shims between evolving API and existing front end. So changes don't break user experience. These actions give the system both coarse grained and fine grained levers. Scaling is blunt but powerful. Feature flags are surgical. They let you cut complexity temporarily. Schema adapters are diplomatic. They smooth over misalignments until team can sync. Together, these forms the action space of the adaptive agents. Now comes the heart of the model, the reward function. In reinforcement learning, the agents act to maximize rewards. But in enterprises, goals are never singular. We don't just care about speed or cost or reliability. We care about all of them. So a reward balances four objectives: meeting SLOs, availability, latency, and error budgets; improving UX, ensuring core web vitals stay within the threshold; minimizing cost, scaling efficiently, avoiding resource waste; and the last one is avoiding risky rollouts, stability during the releases. So here's the key: these objectives compete. Scaling aggressively improves SLO but increases the cost. Turning off features improves latency but harms UX. So the reward isn't a single number, it's a weighted balance across objectives. Think of it as juggling four balls at once. The agent's job is to keep them all in the air without dropping one. This multi objective reward ensures that adoptions are intelligent trade offs and not knee jerk reactions. So, how does the system learn? We use actor critic reinforcement learning. The actor proposes actions: scale, toggle, adopt. The critic evaluates: did that action improve latency, cost, or UX according to reward function? Over the time, the actor refines its policy to maximize long term reward. But we add two important enhancement: entropy regularization. This prevents the agent from converging too quickly on one strategy. It encourages exploration, so the system keeps discovering better trade offs instead of getting stuck. Safety layers. These constraints the agent so it never takes catastrophic action. For example, it can't scale down to zero in production or toggle off compliance critical features. This combination, actor critic, RL, entropy regularization, and safety constraint give us an adaptive system that is both intelligent and trustworthy. So modern systems fail not because we don't deploy fast enough, but because we drift. APIs drift, user interfaces drift, even traffic pattern drifts. And when drift goes undetected, it shows up a broken user experience. invisible performance regressions or outages that scale faster than what we can contain. Drift detection and traffic optimization are divided into three parts: API drift detection, UI drift detection, traffic optimization with sequential canaries. So let's look into the loop to ensure resilience. API drift detections. In microservices, APIs are the contract that glue everything together, but those contracts change constantly. A new endpoint is added, a field is renamed, or a type is modified. Some changes are safe. Adding an optional field, fine. Some changes are dangerous. Changing a string to an integer, suddenly dozens of consumers break. This is API drift, and the innovation here is detecting it with semantic analysis. Instead of just checking syntax, the system understands meaning. If a schema introduces an incompatible type, it flags it as a breaking change. If a field is added in a way that consumers can ignore, it passes. Think of it like proofreading a legal contract. You don't just check spelling, you check whether clauses still mean what they should. Semantic drift detection does the same for APIs. This prevents backend team from unintentionally pulling the rug out from under front ends, partners, or downstream services. Now let's move from APIs to the UIs. User interfaces drift too. A front-end update changes the DOM structure, shifts performance budgets, or alters accessibility rules. This is where the UI drift detection comes in. Here the system compares the DOM tree edit distances, literally measuring how much the document structure has changed, and pairs that with RAM performance deltas from real users. It's not just the DOM change, it's the DOM change and largest contentful paint increase by 200 milliseconds. That combination tells us whether a change was cosmetic, functional, or harmful to UX. Think about it like going to a doctor. A scan shows structural changes in your body, but it's the combination with the symptoms that reveal whether it's a real issue. UI drift detection works the same way: structure plus performance. This ensures regression don't creep into user experience unnoticed. So we have covered the drift detection, APIs, and UIs. But what happens when we release changes into live traffic? This is where the traffic optimization comes in. The key technique is sequential canary testing. Instead of pushing a change to everyone, you release it gradually to small slices of traffic. But here's the notch. We optimize canary rollout to minimize expected error while maintaining detection power. In plain terms, we want to catch problems early before they hurt too many users. But we don't want to be so conservative that we never detect real regressions. Sequential canaries use statistical methods to balance these goals. If a change starts failing in early cohorts, the rollout stops immediately. If it passes, traffic expands safely. Think of it like a vaccine trails. You don't give a new vaccine to the entire population on day one. You start small, monitor carefully, and expand as safety is proven. Sequential canaries bring that discipline to software traffics. The last section is guardrails and rollouts. So let's talk what happens when thresholds are breached. This is where guardrails come into play. If API drift introduces breaking changes, if UI drift worsens core web vitals, or if canaries start failing, the system doesn't wait for human intervention. Guardrails trigger instant rollback. This is what makes it a closed loop system. It doesn't just detect a drift, it contains it. Issues are caught before they spread widely, and users are protected from ripple effects. Rollback isn't a punishment, it's a safety net. It ensures that innovation continues at speed, but without risking catastrophic failure. So McKinsey research shows that enterprises loses 20 to 30% of developer productivity to cross-team coordination overhead, firefighting rollouts, and manual remediation. That's the time not spent building new features, but simply keeping the lights on. So the question is, can we do better? That's where the agentic control plane, ACP, comes in. And when we compare ACP to the baseline, the improvements are striking. First, look at the latency, adaptation latency, and how quickly the system reacts to change. In baseline system, adoption is slow because every layer must be manually aligned. Backend schemas, drift, front-end breaks, SRE scramble to coordinate fixes. With ACP, adoption latency is reduced by one third. Why? Because the cognition plane and execution plane closes the loop. Drift is detected automatically. Candidate fixes are proposed, and rollouts are staged with minimum human input. McKinsey's 2023 State of DevOps surveys reported that elite performance recover from failures 2,600 times faster than laggards. ACP takes organization closer to the elite brand, shifting from reactive fighting to proactive adoption. The takeaway, when ACP is in place, changes don't linger in limbo, they adapt fast with stability. Second, the error rates. In baseline system, error rate spikes during rollouts. We've all seen this. Canaries fail, dashboards light up, Slack fills with urgent pings. ACP changes that dynamically. Because of stage ramping and sequential canaries, error rates are either lower or unchanged compared to baselines. McKinsey's research on digital resilience highlights that organizations who invest in progressive delivery on automated rollback cut incident severity by up to 70%. ACP optimization those practices, turning them from aspirational best practices into system default. The result? Safer rollout where users don't feel the pain. Third is the SLO attainment. Baseline system often sees service level objectives, latency, availability, error budgets, T grade under stress. The more complex the environment, the harder it is to meet the promises. With ACP, SLO attainment improves. Why? Because the reward function inside the cognition plane balances multiple objectives. Meeting SLOs, protecting UX, minimizing cost, and avoiding risky rollbacks. McKinsey estimates that companies who consistently meet SLOs see 15 to 20% higher customer retention compared to peers. Why? Because reliability is sticky. User come back when system work as promised. ACP translates that reliability into measurable business impact. Finally, let's talk about manual intervention. In the baseline, engineers spend hours coordinating cross layer changes, backend schema updates, front end patches, traffic routing, rollbacks. It's high toll, high stress, and low value. ACP reduces manual interventions significantly. Engineers are no longer in the loop for routine fixes. The system handles them. Humans only step in at the policy defined thresholds. McKinsey research shows that reducing developer toll can unlock 20 to 40% more capability for innovation. In dollar terms, that millions annually for a mid to large enterprise. The story is simple. ACP frees human talent from firefighting, allowing them to focus on innovation. So, when we talk about adapting systems, it's easy to think of theory, architecture, algorithm, rewards, functions. But what matters to leaders is proof. Proof that these ideas hold up in the messy reality of production environments. McKinsey's research on digital resilience shows that organizations who adopt intelligent automation frameworks see a 20 to 30% reduction in downtime and 20% and two times improvement in time to recovery. The agentic control plane is an example of exactly that shift. So let's ground this into three real world case studies. So the first case study comes from e-commerce. A pricing schema change, something as small as renaming a field, broke both the cart and the product pages. In baseline setup, that would have meant broken checkouts, lost transaction, and a customer frustration. ACP detected this contract drift automatically using semantic analysis. It flagged the breaking changes, proposed a schema adapter, and rolled it out progressively. No visible impact to customers. McKinsey's benchmark shows that in retail, even an 1 hour checkout outage can cost millions in lost revenue. With ACP, that loss was avoided entirely. It's resilience with measurable business impact. The second example comes from SaaS analytics provider. A new feature introduced significant JavaScript bundle bloat. Users started experiencing slower load times, and RUM metrics like largest contentful paint reached thresholds. ACP detected the drift in real user monitoring, proposed a fix, lazy loading the new features, and orchestrated safe recovery without pulling the feature back entirely. McKinsey's research highlights that every 100 milliseconds of latency reduction can improve user conversion by 1% into digital services. By, by catching the regression early and recovering gracefully, ACP turned what could have been a churn risk into a non-event for customer. The third case study comes from multi-cloud migration. During a query hotspot and regional failover, traffic spiked unpredictably. Without intervention, downtime was immediate. ACP applied predictive auto-scaling using reinforcement learning on orchestrated safe traffic shift across region. The result was reduced downtime and uninterrupted service continuity. According to McKinsey's digital infrastructure study, enterprises that adopt predictive scaling management report. So as we wrap up, I want to shift gears and look forward. We have seen how the agentic control plane works today. But the real question is, where do we go from here? What's next for the agentic AI in microservices and micro frontends? First direction is probably safe autonomy. Right now, we rely on policies and guardrails, but the future is machine checkable policies. Imagine a system where every action an agent takes is mathematically proven to be safe before it executes. It's the difference between saying, we have tested it and it seems fine, versus, we know it cannot violate compliance, budget, and safety rules by design. This takes us from trust but verify to trust because it's verified. That's the foundation of dependable autonomy. The second direction is smarter arbitration among multiple agents. Today, the superintendent agents plays referee, but as the systems scale, arbitration needs to become more dynamic, weighing dozens of competing goals like cost, latency, UX, and compliance simultaneously. Think of it like an air traffic controller. One plane is asking to land, another wants to take off, and the tower must optimize across weather, runway availability, and safety. Smarter arbitration will do the same for digital systems, ensuring harmony even when hundreds of agents are negotiating at once. Third, automated contract evolution. We have talked about drift detection, but the next system is self healing contracts, systems that automatically generate temporary adapters when API evolves and retire them when the team covers. It's like having a live translator between two teams who haven't agreed on a language yet, bridging gap instantly without slowing down delivery. Fourth one is unified observability. Today we monitor traces, logs, and user metrics separately. The future is correlating all of them. Backend traces tied directly to front-end user experience. That way, when a checkout slows down, the system doesn't say latency increase. It tells you this database query caused a 200 milliseconds regression in largest contentful pain for 20% of users in Europe. It's not just observability, it's actionable insights. Finally, governance at scale. Managing one or two micro frontend is doable. Managing dozens across multiple frameworks and regions isn't. The future lies in governance framework that scale gracefully and ensuring consistency in design tokens, accessibility, and policies across hundreds of independent teams. So what's the big picture? Agentic AI shows us that autonomous coordination of micro frontend and microservices is not only possible, it's practical. It reduces adoption latency, it lowers manual toll, and it prevents safety and explainability even as complexity grows. This is the bridge between the speed and trust. between autonomy and governance. Thank you for your time and attendance. The future is not just about faster code or more resilient services. It's about intelligent systems that coordinate themselves responsibility. Thank you so much.
Thank you so much, ma'am, for sharing your insights and expertise. So, before we closing this session, we have a look at short documentary that is Evolution of AI. This video is made of our students of third year CSC.
A huge machine full of wires and tubes that could do in seconds what once took people days, marking the beginning of a new era of technology.
This is where it all began. Fast forward to the 1980s and 90s, where colorful visuals of neural network diagrams come to life. Scientists experiment with early machine learning, and the internet starts to weave its magic. We witness key milestones, like IBM Deep Blue defeating a chess grandmaster, a pivotal moment in AI history. Then, we dive into modern breakthroughs, deep learning algorithms and data centers filled with glowing servers. As we transition to the future, we see ChatGPT in action, humanoid robots, and smart assistants, showcasing the incredible advancements we've made.
Ava, initiate self-assessment protocol.
Self-assessment protocol initiated, David.
Meta CEO Mark Zuckerberg is laying out his vision for how the social media company uses artificial intelligence. Zuckerberg says that the goal is to focus on what he calls personal super intelligence, aiming to make everyday tasks easier and faster. Zuckerberg also posting a video on Instagram.
Impact in our lives is going to come from everyone having a personal superintelligence that helps you achieve your goals, create what you want to see in the world, be a better friend, and grow to become the person that you aspire to be.
Revolutionize search and rescue and disaster response. They could also transform how packages are delivered. But there are limits to what large, single drones can do. More complex tasks will require teams of small, nimble...
It's not just following instructions, it's figuring out its own instructions. It comes up with moves that humans hadn't thought of before. So
Hi there.
Questions. Grok 4 is better than PhD.
Thank you so much. And now we are invited Dr. Pramod sir to please give a vote of thanks.
Thank you so much, ma'am. Good afternoon, everyone, and welcome to all. Thank you very much for inviting me to propose the vote of thanks for this tremendous and amazing conference. Respected chairperson, distinguished speakers, faculty member, dear colleagues, students, and lovely audience. This is Dr. Pramod from the Department of Applied Science and Humanities, IIT. It is my proud privilege and profound honors and pleasant duty to rise before you to propose the vote of thanks on behalf of the organizing committee at the concluding session of Enriching International Conference on Future of Computer Science with AI, Theory, Practice, and Impact. First and foremost, I would like to extend my sincere thanks to the keynote speaker, Dr. Sanghyuk Lee. Sir, your lecture was not only the erudite and the insightful, but also opened new dimensions of thoughts for all of us. The seamless bridge theory with the practice research and application and innovation with impact, the clarity with which you articulated the challenges, opportunities, and ethical imperatives of artificial intelligence has left a deep imprint on our minds. You illuminated how AI is not simply a technology, tools, but also a transformative force with profound implications for humanity's society and the future knowledge itself. Dr. Lee, your scholarship and global perspective enriched this academic platform and set a high intellectual tone for this entire conference. We are truly privileged to have benefited from your wisdom, experience, and futuristic vision. Thank you, Dr. Sanghyuk Lee, for being with the guide star of this conference. From the bottom of my heart, I would express to my sincere thanks to both of you, the chairpersons, Professor Atulgiri, Mayagiri, Gonsai, and Dr. T. Velumurugan, who did their job sincerely and punctually as the chairperson. Sir, your gracious presence would be graceful for all of us. And thank you so much for your valuable time and being with us. I would like to extend my grateful and sincere thanks to each of you gracing this international conference on future computer science with AI, theory, practices, and impacts. As invited speaker, Professor Atulgiri, Mayagiri, Gonsai, Dr. T. Velumurugan, and Mrs. Jyoti Kunal Shah. Professor Atulgiri, Mayagiri, Gonsai, your enlightened us talk has broadened our understanding this theoretical underpinnings of the computer science in this age of AI. The depth of your analysis, the clarity of your explanations, and the intellectual richness of your ideas have truly inspired us to look at AI not merely as the discipline of technology, but as the field of this transformation, human knowledge, and social progress. Dr. T. Velumurugan, your session was perfect blend of theory and practice. You articulated with the remarkable perception how research in AI can be translated into meaningful real world in applications. Your insight into the algorithm, computationals, and models and their impact on society were both practice and visionary. You have motivated us research scholars and scholars to pursue the innovations with their balance of the rigors and the responsibility. Mrs. Jyoti Kunal Shah, your perspective brought refreshing and practices-oriented dimensions to this conference by sharing applied the insight and pragmatics frameworks. You highlighted how AI is not confined to laboratories and theories, but also actively shaping industries, governing, and daily life. You talked how bridge the gap between the academic research and the practical implications. Together, your contribution have added immense valuable and intellectual depth to this conference. Each of you, in your own unique way, help us to better appreciate this theory, practice, and impact of AI in evolving landscape of this computer science. I would like to express my sincere thanks to organizing committee, the entire academic fraternity, and the volunteers, participants, and the lovely audience. I would like to also express my thanks to all the media, both print and electronic, who are going to give their best to make this conference grand and memorable. The last but not least, I would like to extend my thanks to all those whosoever, whether they physically present or not. And also I would like to thanks to all the people who are also us supportive in each and every possible way. We look forward to your continued association in our future endeavor. Thank you all of you. Thank you, sir.
Thank you so much, sir. So kindly request to join for lunch, and we will start the technical session at 3:15 at 3:30 at NB Hall IET. Okay, thank you so much to all.